All right, let's go ahead and jump into Geometry 4.11. It says, in the past, we described the difference between SSA and HL, which is technically two sides and a non-included angle being congruent. What were the qualification for the angle when SSA can be used and is called HL? Well, the main thing is that that has to be a right angle. If it is any angle other than right angle, I think it might also work with obtuse, but they stick to right. So we're going to be doing it if it is a ASS, also known as SSA, and that angle is right, we are going to call it HL. What I'm doing now is I show you a full proof where we use HL. And rather than telling you how to do an HL proof, I wanted you to look through and try to find how this is different from proofs we've already done and how it's the same. Is the following is a filled out proof for HL, analyze the proof and identify what is necessary to be included in HL proof. So when we go through this, it says what part of the HL hypotenuse leg is AB and BC. That's going to be a leg is congruent to a leg. That is just two sides that are not the hypotenuse we call legs. It didn't matter which ones they were. So a leg's congruent to a leg. What part of HL is BM and KB? BM and KB are the hypotenuse. So that's a hypotenuse congruent to a hypotenuse. And then it says, does it look like it is enough just to state that the angle is right in HL? If not, what else is included? It seems like they went over and state that the angle is right, which is usually given, and then they have to state the triangle is right, and that's definition of right triangle. So this is the main difference between how we have used right angles before and how we use them now. If you are finishing with anything other than HL, this is the main most important thing. Finishing with anything other than HL, so SAS, ASA, AAS, if you're going to finish with those and you are using a right angle, you state that all right angles are congruent. That is what we have done this whole entire time. Now, if you are going to finish with HL, you state that the angles are right, and then you write down the two triangles and say the triangles are right. It's a weird little quirk. I wish we could just skip it because this is the main thing that people always mess up on with HL. You don't state that the angles are right, therefore they're congruent. For HL, we don't care that those angles are congruent. We care that the triangles are right. So that is why you have to have that in there. You have to have a hypotenuse congruent to hypotenuse, leg congruent to leg, and in your proof, you have to state that the triangles are right. The angles are right first, and then the triangles are right. So that is the main, most important thing to remember from HL. Quick notes. HL hypotenuse leg is a special case where SSA that actually works. The angle must be right. There's a step after saying that the angle is right where you state the triangles are right. Rather than saying the angles are right, they are congruent, you say the angles are right, therefore the triangles are right. Now on here, it says below are two proofs of the same set of triangles with different givens. Find the differences and similarities between how the proofs are created. So on here, if you put the marks in there, what are the similarities? They still show a leg is congruent to a leg and a hypotenuse is congruent to a hypotenuse. Both of them do it, but one of them finishes with SAS and the other one finishes with HL. Now, the one that finishes with SAS ends up having an angle congruent to an angle between the leg and the hypotenuse, whereas the one that finishes with HL, you are going to go over and use a right angle, which makes it a right triangle. What is the main difference? The hypotenuse and legs are just sides that are congruent, could be both legs. And then number two, the difference is the right angles are either used as congruent angles or they are the precursor of the triangles are going to be right. And then you had to fill out the students went over and actually did an HL proof. So the thing that is going to lead to something else is the angles are right. That's given. Now, if this was finishing with anything other than HL, you would have said the angles are congruent because all right angles are congruent. But in this case, you state that the two triangles are right by definition of right triangles. Then you have your given the reflexive property, and that all comes together to be HL. Now, the stuff about the angles being right couldn't be in either one of the other boxes because it leads to something, but the given and the reflexive property could have switched if you wanted to. Now, for the homework. After stating that two triangles are right in a proof, when finishing the proof with HL, the next step is stating that instead of saying the two angles, or after you state the two angles are right, then you would state the triangles are right by definition of right triangles for HL. For anything else, you would say the angles are congruent by all right angles are congruent. Number two, the difference between SSA, which is not allowed, and HL is basically that HL is SSA where the angle must be right, because there won't make two possible triangles, it'll make only one. On this one right here, you guys are filling in the proof. You have a block of information stating the angles are right, which is given, therefore the triangles are right, definition of right triangles. That is a block. That block could have gone anywhere in your proof. Then you have another block, which is CA and BD are congruent. That's given. And then you have AD and AD are congruent by the reflexive property. And that is another block that could have gone anywhere in your proof. And this is going to be HL. This is why it's super important for you guys to first figure out how you're going to finish your proof before you start. Because if you start this without knowing it's going to HL, you're probably going to say the angles are right, therefore they are congruent, because all right angles are congruent. But that is not used in HL. We don't care about the angles being congruent. We care about the triangles being right. Explain why you would not use vertical angles theorem in the following proof. Well, if you said vertical angles theorem, then that is saying an angle is congruent to an angle, and then you are using ASS or SSA, which you're not allowed to. Instead of using those as vertical angles, you're using them as right angles. And if they're right angles, on here we have a leg and the hypotenuse and the hypotenuse. So this is going to be HL. So instead of looking those as vertical angles being congruent, we care about them being right angles, so the triangles are right, so that we can finish with HL. You guys were supposed to go ahead and do this proof. You're going to state the angles are right, therefore the triangles are right by definition of right triangles. You have it's a midpoint, therefore these parts are congruent by definition of midpoint. And then the last one is your given, and it all comes together to be HL. If it was finishing with anything other than HL, after you state that the angles are right, you would state that they are congruent, because all right angles are congruent, but not with HL. A little bit different with HL. Okay, I hope this made sense, the difference of how you use right angles with HL versus how you use right angles for everything else. Thanks for watching.